In episode 2 of Solving Linear Equations, we're going to look at using the multiplicative inverse as well as the additive inverse. We looked at the additive inverse in episode 1, so we're going onto slightly more complex linear equations now. And let's have a look at the first one. 3x plus 2 equals 17. So if we remember the methods that we used yesterday, we're trying to get our x terms onto one side and our constant terms, our number terms, onto the other side. So if we look at this, if we keep the x on the left hand side, then that's the number term, the constant term that's in the wrong place. So we're going to start off by writing what we have, 3x plus 2. Using the additive inverse, if I'm minus 2, then 2 minus 2 is going to give me 0. And I have then already got 17 on the right hand side. And whatever I do to the left hand side, I have to do to the right hand side. So cleaning up, we're going to see 2 minus 2 is 0. So here I'm only left with 3x. And then seeing now what the right hand side is equal to, 17 minus 2 is equal to 15. So that's the method that we were using in the last episode. That's as far as we got. But because we didn't have a coefficient of x higher than 1 in episode 1, this was the end of the story. But we're not trying to find the value of x at 3x, we're trying to find the value of x. So if we consider that 3x means 3 times x, the inverse of multiplication is division. So I then need to divide by what I'm trying to get rid of, and I'm trying to get rid of that 3. And if we think about it, 3 would go into 3 once, and 3 would go into 3 once, so I'd be left with x. So when we get to this stage, we don't have to think, it's no rocket science involved. You look at what the coefficient is, and you divide by exactly that coefficient. But whatever you do to the left-hand side, you have to do to the right-hand side. So therefore, here I'm just left with x, and here I'm left with 15 divided by 3, which gives me 5. Let's again check our answer. If we put 5 in the place of x, we would have 3 times 5, which is 15, and 15 plus 2 does give us 17. So we've got the correct answer. Now we're going to start really looking at what's going on here with the additive inverse. If we had plus 2, then it actually became minus 2 on the other side because we were using the additive inverse here. So we're not going to write this step down every time where we show that if it's plus 2, we're going to say minus 2. If it was minus 2, we would have said plus 2. We're just going to remember a shortcut now, that if a term goes over the equal sign to the other side, it changes its sign. And it doesn't matter whether it's going from the left across to the right or going from the right across the left, which is going to happen just now, it will change its sign. So we're just going to make this step easier by remembering that. So looking at these 3 terms here, I have a constant, I have an x term, and I have a constant. So the one that's on the correct hand side is my x term, and this one is on the incorrect side, so I'm going to be taking it across. But first let me write down what's going to stay here. What's going to stay here is negative 5x, and be very careful that you don't write down 5x. Remember, the sign that is in front of a term belongs to that term. On this side I've got negative 11, and it's not going to move because it's on the correct side. Now that 4 needs to be on this side. So remember, if there's no sign in front of it, it's positive. So when it moves to the other side, it's going to become negative. So now I do my tidying up step. This is going to be simply as it is. And negative 11 minus 4 is negative 15. Let's keep doing this at this stage because we've only looked at it in this episode. So I have to divide by whatever the coefficient of x is. And if the coefficient of x is a negative number, I have to divide by a negative number, because negative divided by negative will give me positive, and 5 goes into itself, 5 goes into itself. So I'm going to be just left with x. And then whatever we did to the left-hand side, we also have to do to the right-hand side. Exactly the same thing, not divide by 5, but divide by -5. And again, negative divided by negative is positive, and 15 divided by 5 is 3. Right, sometimes things can be configured in a slightly different way. So let's have a look at something like this, getting a little bit more interesting. Right, so if we look now, we haven't got 3 terms like we've been working with most of the time. We've got 4 terms. 1, 2, 3, 4. They're separated by minus signs, plus signs, and equal signs. So I'm just going to go through each term, deciding is it in the correct place, isn't it in the correct place, and then deal with it with an additive inverse. So 2x is on the left-hand side, so I'm going to leave it here. -8 is going to move across. I'll do it when I get there. 4x is on the right-hand side, and I need it on the left-hand side. So positive 4x is going to become minus 4x. Have I got any more x's that need to come across? No, that's it. So now I write down my equal sign. I always like to start off with what I've already got on the correct side. So 6, I'm not writing plus 6 because plus 6 means 6. And this 8 was on the left-hand side. I need it to be on the right-hand side. So minus 8 is going to become plus 8. 2x minus 4x, they like terms, so I can subtract them. And 2 minus 4 is negative 2x equals 6 plus 8 is 14. Then I need to get x on its own, so I'm going to divide by exactly what the coefficient is. Do the same to the other side. Negative divided by negative. If you've divided by this exact same coefficient, you will always get positive x because you'll have a negative divided by a negative. And then here we've got positive divided by negative, which is negative. 14 divided by 2 is 7. So it doesn't really matter how many terms you have on in an equation, as long as you remember, get the x's on the one side and the constants on the other side. So the next one I'm going to do in 2 different ways. Let's just set it up twice so that it's all ready. And in this, I'm going to show you that as long as you follow the mathematical rules, there are various ways in which you can approach something as long as you are doing everything mathematically correctly. So when I do this one, I've got 3 terms. And for now, I'm going to stick to what I've been saying all the time. Get the x's on the one side, the numbers on the other side. So let's do that here. So first of all, my x is on the right-hand side, so I have to bring it across, and negative 8x will become positive 8x. This 5 is already on the correct side, it's on the right-hand side. Negative 3 is on the left-hand side, bring it across, and it will become positive 3. This 8x is going to remain as it is. 5 plus 3 is 8. I don't want 8x, I want 1x, so I divide by exactly what that coefficient is. Do the same to the other side. Therefore, x is equal to 8 divided by 8 is 1. But I could very well have said, seeing as my x is on the right-hand side, I'm going to leave it on the right-hand side and I'm going to bring my constants to the left-hand side, because the important thing is the variables must be on the one side and the constants on the other side. Most of the time we work with x being on the left-hand side, but this time let's do it with leaving x on the right-hand side. So negative 3, because my x is going to be on that side, my numbers are going to be here, so the negative 3 is on the correct side. The 5, I need to bring it to the left-hand side. Positive will come across as negative. And on the right-hand side, I have negative 8x, and it is remaining negative 8x because I haven't moved it to the other side. So negative 3 minus 5 is negative 8. And here I have negative 8x. Whether your x is sitting on the right hand side or as it was here sitting on the left hand side, it makes no difference. You want to solve for 1x, so you're going to divide by exactly what the coefficient is. Here it's negative 8. Therefore, I must do the same thing to the other side. And therefore, I'm going to get x equals negative 8 divided by negative 8 is 1. So I'm getting exactly the same answer. I did it in a slightly different way, but I adhered to all the mathematical rules, and therefore I will get the correct answer.